Alright, welcome back to another installment of Math Mondays. I hope everybody's doing well. With that said, let's get on to today's lesson, which we're going to be discussing inscribed angles. Alright, before we start solving problems with inscribed angles, let's first define the term. An inscribed angle is an angle formed by two chords in a circle which have a common endpoint. So in terms of a circle, what does that look like? So if I have my circle here, I'm going to call it circle C. Remember, we name our circles usually by the center point of the circle itself. And if I was to make an inscribed angle is made from two chords. A chord is just a line segment that has its endpoints, both endpoints on the circle. So here is a chord, and then here to here is a chord. This angle that they form is an inscribed angle. And through the inscribed angle conjecture, we are given the relationship between the intercepted arc and the inscribed angle. And that relationship is that the intercepted arc is twice the inscribed angle. So what do I mean by that? If my angle, my inscribed angle, let's say that is 40 degrees, my intercepted arc which I'll do in yellow here, perfect. I'll call that point A and point B. So my intercepted arc in yellow would be twice that of the inscribed angle. So if my inscribed angle is 40, twice that will give you 80. So this intercepted arc is 80 degrees. So knowing that conjecture, I'm going to show you how to solve a problem using that. Alright, here's one of the example problems I pulled from one of the quizzes. This should be pretty close to the actual question they were asking. I drew it up, and we'll go ahead and try to solve this. It says, given that BD is the diameter of the circle E. So we have our circle, center is E, and they're saying that BD is the diameter. So B to D is the diameter. What does that help us with? If this is the diameter, its intercepted arc is this. So if this cuts this circle in half, this arc is 180 degrees, and so would this be. So we know that from B to D, our intercepted arc is 180 degrees. So I'm just going to quickly label that. So from B to D is 180. So what information we're given? We're given 51 degrees for angle DBC, and that is our intercepted arc. So we're using our properties of intercepted arcs. We know that the angle is half of the intercepted arc. Therefore, this intercepted arc from here to here, D to C, would be twice that. So 2 times 51 should give us 102 degrees. So now we know from D to C is 102 degrees, and since we know that this is the diameter, we know that this whole arc is 180 degrees. So if we just go from D to C, where we have 102 degrees, and the whole thing makes up 180 degrees, that means what's left over from B to C, arc B to C is what we're trying to find out, would give us our answer. So we know that we're at 180 degrees. So We have 102 degrees already from D to C, and find B to C is what's left over. So we just subtract those. So that means from B to C should be 78 degrees. Hope this quick lesson helps. Remember, the key component, or key takeaway from this lesson I want you to know is the inscribed angles, that the intercepted arc is twice that. If you're given the arc itself, let's say I get this 102, you can work backwards and you can get the intercepted arc. The intercepted arc would be half of this. But if you're going from the inscribed angle to the intercepted arc, you double it. Hope that helps, and keep on working. If you have any questions, contact me via text, email, or you can give me a call. Have a good day.